are the enablers that help us bring our ideas to fruition. And over the past year, we've seen a crazy shift in how much web developers care about the tools they use on a daily basis. You're starting to get a lot more passionate about those tools because those tools keep you effective and they help you be your best. So today I'm going to talk to you about tooling for the modern web app developer, and I'll hopefully introduce you to some ideas and some tools that can help keep you effective. So I see there being four main groups of tools that people use these days. There's the browser and your dev tools, which you use for debugging. There's the text editor, there's the terminal, and then you have your devices or emulators that you use for things like mobile. Now I'm going to start off with the Chrome developer tools. So the Chrome developer tools are constantly evolving. We're actually landing new features in them almost every week. And actually, just to take a straw poll, how many people here use the Chrome Canary as their default development browser? I love Paris. Right, so you should be, for those people, I think there's probably half the audience that aren't doing that. You should definitely be trying out Canary for your development, because not only do you get features first, but you'll also be seeing a bunch of experimental stuff that you can enable in Canary, but not in Stable, that will help you with your day-to-day workflow. Interesting fact, it's only about 11 weeks between features landing in Canary and then being shipped to about 311 million users on Stable. So there isn't a huge amount of gap between the time that you start using a feature and it being available to a lot more people. Now, we recently started trying to get a little bit more awareness on this, but if you go to Chrome Flags and you find Enable Developer Tools Experiments, enable that and restart your browser, you'll actually have access to a ton of other stuff that you currently don't have in Stable. So if I actually pop open my tools and I click on the cog in the very corner, I go to Settings, you'll see that there's now a tab called Experiments there. And that has a bunch of new features that you can try out. And a lot of these are actually stable and can be used today. Now the first thing that I'm going to be talking about is performance. These days, a lot of developers are aiming to create high-performance web applications. We want rich animations, we want 60 frames a second, and tools like the developer tools have to evolve to help developers debug those situations and achieve those high-performance 60 frames a second that they want. Now, the timeline is something that basically allows you to see where memory is being used in your application. So I have an application, a little application we wrote running at the side. It basically loads in new images whenever I scroll down, and I can also use it to sort of open up larger images. Now, I've opened up the timeline. You won't actually see any data in here when you first open it up. The idea is that if you press the button at the very bottom of the screen with the black circle on it, it'll actually start recording. So let's do that and see what happens. Let's start off by talking about events. So I'm recording. I'm just scrolling down my page, and you can see the views populating with a lot of data. So let's stop that. Now the top pane is called the summary view, and here we can see 3 rows of different pieces of data. Now the top row in blue represents loading, so things you might be loading in like HTML. The second row is JavaScript, and the third row are paint and rendering events. Now if I go and I select a range in here, I can actually drill down and see these in more detail. Now, although the timeline is supposed to be used for performance analysis, I like using it to see what is actually going on in an application. And you can do this without necessarily having to go and view the source. So let's take a look at the records on the side and see what's going on. So we can see that there are an awful lot of scroll events. We've also got a lot of painting. So I can already tell that in this application, something happens whenever I scroll, and it's trying to paint new things to the screen. And we can also drill down in any of these. So if I hover over them, I can see some more information about that particular block. I can see how long a particular event took to occur. But I'm interested in drilling down to some of the paint events. And I can actually use this to see any pain points that I might have in my application to do with events. So in this case, I can see that, I'm not sure if people can read this, but at the side, I've just drilled down into a paint event, and I can see that there's image decoding going on and image resizing. If I continue going down, I can see that there are more of these. There's a lot of image resizing going on, and this is currently a pain point. Now, if I go to the source code to this application, this is the source. It's not a terribly complex application. In this line, what I'm actually doing is I'm loading in a much larger sized image, and my application is having to resize that, and the browser is having to decode it. What I should ideally be doing is actually pre-scaling the images that I'm using so the browser doesn't have to do all of that work. And that's a good tip for mobile as well. If you avoid sending down complete full-scale images, you can actually save yourself some time when it comes to rendering. Let's go back to the timeline. Now, as I scroll through, I'm noticing a little bit of jank in my application. It's a little bit sluggy. It's perhaps not as smooth as it could be. So I'm now going to go to frames. Now, frames mode is very interesting. It basically helps me see how many frames per second my application is getting. And each of these bars that you see at the very top represents one frame that WebKit has had to render for your application. So let's try profiling our application again. I'm going to clear the results we had before, start this again, and let's start recording. So this time, I want to see what happens when I actually display larger images. I'm going to stop that. Now take a look at that data in the summary pane at the very top. Now ideally, I want to be having all of these bars right beneath the 60 frames a second, because that's what's going to give me the fast, snappy experience that I want to give my users. In this case, we're seeing that we're, in some cases, not even hitting 30 frames a second. Let's go and drill down. So select a block, and let's see what's going on. So we're seeing a lot of image resizing in the pane events, which is interesting to me, because I currently actually have an event bound to the window, so that whenever you resize it, we do stuff with the images. And this means that if I want to try to figure out why my application is not getting the frames per second that I want, maybe I should be taking a look at that code. Let's see if there's any other information that I can learn about this. So let me go to the memory pane. Now, in the summary view at the very top here, this is basically giving you some insight into the heap for your application. Now, let's do some actions on this once again. Let's hit record. Let's start scrolling. Let's start viewing different things. Let's stop. Let's drill down. Now, at the very side, I can actually select whether I want to continue to display the document count, the DOM node count, and the event listener count in this view. I'm really just interested in the DOM node count at the moment. Let's view a slightly wider range. And this is very interesting to me. This is a step function that I'm getting from my JavaScript application. This is surprising to me because I'm not actually doing that much when I'm clicking on these images to display larger versions. I'm not creating new images. I'm not creating new DOM nodes, ideally. And so this gives me an indication that there might be some sort of memory leak in my application. Now, normally in the timeline, I'm actually able to drill down to specific lines of code that might be causing problems. But in this case, I'm not entirely sure what's going on. So maybe I want to use another tool. So we've got profiles to help you with this. Now, profiles are really great because they can give you some insight into what's going on with the garbage collection in your application. They can also help you with things like profiling the execution time for your JavaScript functions and how long it's taking for selectors to match the CSS in your app. In this view, we're actually very interested in the heap snapshots, which show the memory distribution among all of the live objects in our page. So let's take a heap snapshot of where we are right now. So that's a single snapshot, and it shows a bunch of different constructors and objects. That's great. Now, in order for this to be useful, we're actually going to take another snapshot. I'm going to perform a few different actions inside the application. I'm going to take another snapshot. Now, at the very bottom, you'll actually see a few options that you can select. The summary view is generally used when you're interested in trying to find out if there are DOM node leaks in your application, whilst the comparison view can help you figure out what memory leaks may be there. So let's click on comparison. And what you can see here are the objects that are left over after we've gone and done another snapshot. It also helps with debugging if you use, back in timeline I probably forgot, there's actually a button here, the little trash can will actually allow you to force a round of garbage collection while you're debugging, just in case people aren't aware of that. Anyway, back to heap snapshots. Now let me take a look at all of these different objects. It tells me how much size is allocated. It tells me the difference in size between these objects from what I had before and what I had after my last snapshot. Now let me drill down. I can see that I have some detached DOM nodes. And when I drill down further, I can see that there seems to be an image on a detached DOM tree that is still hanging around. Something is still having a reference to it that ideally should probably not be there. Now in the objects retaining tree at the very bottom, if I expand on that, and I continue drilling down, I can see that this reference is actually on the window. So somewhere in my code, something is referencing an image that we tried to detach. And so we haven't properly cleaned that up, and it's causing a memory leak. Now, this just gives me another hint that maybe the 3 things I should be doing in this case to fix my application are making sure that I'm using pre-scaled images in this case, avoiding having my resize handler on the window or coding that more intelligently, and in this case, making sure that there are no more references to the image that I'm using that are just hanging around. So if we go to the code where this is actually going on, this is basically the code that's breaking. And we've got an event lister on the window watching for resize that actually is trying to reference an image outside of it that may or may not actually exist. Now the solution to this is actually getting rid of that block and doing a little check just to make sure that there's no image that's been defined there before we go and we do some other stuff. But the timeline is really, really useful. The heap profiler is really great. I encourage people to check them out. They'll definitely help you build slightly more performant applications. Now, something else we've been taking a look at lately is giving developers a better authoring workflow from within the developer tools. Now, the first thing I'm going to talk about here is something called live edit. So I've got a to-do application open at the moment. This is a backbone one. I'm going to pop open the developer tools. Now, let me go to sources. Now, in sources, I can go and I can, the same way that I would in Sublime or any other text editor, I can start editing the content that I have in my application. So I'm going to try finding, let me change this back to the other view very quickly. So let's see if we can find an interesting event. How about we try finding a toggle event that occurs when a particular to-do is completed. So I'm going to add some additional code here. I'm going to say that. And now when I do a command save, and I go back to my application, let's pop open the console, say, actually what I should be doing is saving this, 1 second. And when I toggle this item as complete, you can see that it's now executed new code that I actually added to my source file. I didn't have to leave the developer tools. I didn't have to go and reopen my application. I was able to make live changes to the source and have them execute in the browser. Now, if I wanted to go and overwrite my original sources, I could just right-click and have access to a number of other features. I can go and I can save as if I want to export this back to some location I can reuse later. But what's also interesting is I have access to a complete revision history. So let's say we did some other changes here. Let's say that just for argument's sake, I did dotJS here and I clicked save. Now if you right-click and you go to local modifications, it'll actually open up a panel that contains all the edits that you made to that source file. And you can revert back to any position that you want. You can go and you can execute code that you were working on 10 minutes ago. If you made changes you preferred then, you can undo all of the changes that you've been trying out. It's kind of cool. Another new thing that we recently added that's available under experiments, so if you go to settings and you go to experiments and enable snippet support, is the ability to store snippets or pieces of code in the developer tools that are always available there for you to use. So snippets are available, let me just close this. So snippets are available under an additional snippets panel in the very corner. Now to demo snippets, I'm going to see, hopefully I still have an internet connection. So I was looking at Google France last night, and I was thinking maybe we could spice this up just a little bit. So let's see, where are we? Now if I go and do Control-Shift-E, I can actually go and execute code in my page and improve what Google France looks like. Now, snippets are basically stored inside local storage, the same way that a lot of the settings for the developer tools are. But you can basically store a lot of utilities. So I have utilities for things like grepping, so I can easily search across all the different objects and features that are available in WebKit or any other object inside my application if I wanted to. So it's a pretty useful feature. Now, another thing that I'm quite excited about is the idea of auto-saving. I don't really like having to switch between multiple tools all the time during my workflow, because it means more time that I'm spending getting used to another UI, even if it's a couple of seconds just to adjust. And I prefer to just be able to make changes in one place and have them persist across my workflow. So one tool that works with the Chrome developer tools to do this is called Tinker. So it's available at tincr.com if the site loads up. But Tinker basically supports the idea of bidirectional editing from within the developer tools. And the idea is that you can make a change, like any change you want, to your styles or your scripts, and it'll persist those changes back to your source files. You don't have to do anything at all. This was amazing to me because I ran into so many cases where I might be trying to tweak up the UI to an application, and I'd just get those perfect styles that I really wanted, and then I'd accidentally refresh the page or close Chrome or close the tab, and there's no way to get those changes back. But with Tinker, those changes are automatically saved to your source files, so you don't even have to worry about that. Hello, Sai. Okay, let's go back. So let's go to HTML5, please, and see how this might work. So I've popped open the developer tools once again. I've gone to Tinker. Now, normally, you have to tell Tinker what type of application you're working on. So now I'm currently serving this application over localhost, so a HTTP web server. I'm just configuring what my application root is. And if I go to the Elements panel now, and how about we select this HTML5, please, and we inspect it. Let's say that I wanted to bump up the font size. Yes, that's definitely more readable now. Now, if I go and I refresh this page, sorry, the Wi-Fi is a little bit slow. Those changes have persisted. I can go back to the source file now, and all of my styles will have been updated to reflect what I've been doing inside the developer tools. This is awesome. Yeah, but I get excited about very small things. You should see me when a new version of Chrome is available. But autosave is pretty cool. Now, another thing that we've noticed a lot of web app developers are doing these days is they're starting to move more and more towards working with abstractions. Some people like working with CoffeeScript, some don't. But on the style side of things, people are really starting to appreciate things like Sass. And a feature that I heard a woo in there somewhere. It's like the one designer in the room. Thank you. So a feature that we recently added is the ability to have a much better Sass workflow inside the developer tools. Now, there's a problem, right? So when you're working with an application, you'll probably already have compiled the Sass for your app. And you'll be working with those compiled static Sass files. So my HTML5 Please app right here, this is actually using compiled Sass files. So when I'm ever editing anything here, this is actually writing back to my static files, my compiled files, rather than the sources. And this is a problem. So if I go and I click on style.css and I go to the editor view, I do get some line information about what's going on in my file, but this doesn't actually matter, because if I go back to my Sass files and I start making changes there and I compile them, they'll overwrite anything that I've been doing. And that isn't the best. So we decided to add some new features to help with this. So if you go back to Settings, you scroll down to the very bottom, and you check Support for Sass. We also have an auto reload feature available in general. So, wow, Chrome is changing so fast. I guess it's done automatically now. I'm going to have to thank the engineers. So now, if I go back to the Elements pane, let's refresh the page. I've got to refresh the developer tools as well. And now, if I go back to my H1, you'll see something quite important. This is now reflecting my Sass source files. I can go and I can click on index H1, and I'm now editing my Sass source files directly within the developer tools. How badass is that? Now, I don't know if this is going to work, but I want to start using a mixin that I created earlier. So let's see if this works. We love our function and mix-in names at Google, so let's see. So now when you've made changes to this, you ideally should be saving it back to the location where you're working. So let me just make sure that's correct. Yeah, save that. And now, what that's actually done, this should be looking much prettier. Let me go back. Oh, what the hell, 40 AMs. There we go. What this has actually done, this is actually spectacular. And I know it doesn't look that impressive. But what this has actually done is it's gone and it's compiled my original SAS source files. And it's now displaying the latest version inside the developer tools inside Chrome. So I don't even need to leave this thing. I can be making any changes that I want inside the Chrome developer tools. I can be using Tinker to save those changes back to my source files for me automatically if I'm working with static files. And if I'm working with SAS or an abstraction layer, I can just be using this workflow, which means less time having to switch between my tools. Now, another thing, this is just a small thing. How many people here use CoffeeScript? Wow, I'm surprised. Okay. Right, so if you use CoffeeScript, sometimes you'll be working in a workflow where maybe you've got a production level app and you want to debug, and it's harder to do that because you might have some compiled assets, some compiled scripts, and it's not really going to tell you what source files you're working on. Now, source URL is pretty cool, and it's best explained in a demo. All right. So basically, what I have here is a very small Coffee compiler. I've got some CoffeeScript source code. And what I'm going to do here is I'm going to create a file. So let's say it's math.coffee. So what this is going to do is it's going to give me the ability to, first of all, compile that code into some CoffeeScript. And then when I go into the sources view, I actually have a screenshot of it here. Go me. So I actually have a screenshot of what happens here. I can actually go and inside the compiled CoffeeScript file, so inside my JavaScript, I'll get a little line comment at the very end that will pinpoint exactly what source file this came from. Now this is something that you can enable inside some CoffeeScript compilers, and it just means that it's a little easier for you to go back from your production code to your development code and just make changes a little bit more fluidly. The next thing I'm going to talk about are some new features we've enabled for mobile debugging. How many developers here have to work on mobile or develop applications that have to work on mobile? Almost everyone should be putting up their hands here because I keep accessing sites that just break in mobile. Right, so what we've done is we've tried to make this workflow a little bit easier as well. So I'm back inside HTML5, please. And in the very corner, this is something that we've done only very recently. We've actually split out overrides into its own panel. Let's expand this a little bit so it's a little bit more visible. So this is the overrides panel. And the first thing I'm going to show you is the user agent and device metric settings. What this allows me to do is basically select a particular type of device. I'm going to enable device metrics. So I've currently selected Android Nexus S on 2.3, and it's automatically populated the device metrics for me. What this has done is it's gone and it's resized the current view to basically be the exact same as it would be on the Nexus S. And it's also made sure that it's emulated the font scaling that I might have on that device. What this basically means is that if I'm working with media queries or if I'm using match media in my JavaScript, it's just a little bit more easy for me to debug these kinds of apps. Now that's cool. Now another thing that you usually want to be able to do when you're working with mobile is see what happens when someone actually starts turning their device. Because you can actually start having specific actions that happen when they do that. They can be turning around their device, they can be flipping it in different directions, and you've probably seen games that work based on the same concept. Now how can you develop that? How can you debug that when you're working within developer tools? Well, we actually have the ability to override device orientation here. So you can override the values for what happens when someone goes this way or whatever. And if you override device orientation, what you'll actually see is that the container in this application is now emulating what would be happening if someone turned their application that way. And you can change these values to basically be whatever you want. It's kind of cool. Now, another thing that we've recently enabled is the ability to do styles inside the Chrome console. So if I go back, let's go back somewhere. Let's go back here. Should be okay. Now, I believe I have a snippet for this. So let's fix this up. This is what the web is all about. So basically the idea is that you're able to pass in styles for any piece of text that you might want to output in your console. Now, although I'm using it because I'm like an 8-year-old boy in this case, because I'm using it in this way doesn't mean that it's not useful. You can use this to basically style any type of output that you want inside the console to help you with grouping and just being able to highlight specific pieces of information a little bit more easily. And we also support multiple style blocks. If you take a look at the screenshot at the very bottom, you can actually pass in multiple words or multiple word blocks and multiple styles so that you can actually have different colors or different styles on each piece of text in a string if you wanted to. Another quick tip that people aren't always aware of is the ability to inspect stuff directly from the console. So what have we got on this page? We've got a class main, we've got a container. So if I wanted to inspect the document, like if I wanted to inspect the document body, for example, I can just directly do that from inside the console. And it'll then flip back to my elements view, and it'll highlight particular elements that I wanted to inspect. It's just a nice little quick pro tip. Now the next thing that we think is important inside your workflow, right? The command line is very, very important. You should definitely take a look at some of these tools that I'm going to be posting later on. Linting, very, very important. You can now unit test in the cloud, build systems, very, very important. Yeoman, you guys should check out Yeoman. It's really, really awesome. It helps you go from prototypes to applications in a very short space of time, and it helps you limit boilerplate, takes care of authoring abstractions, scaffolding, linting, library load, testing, build tools, oh my god. So Yeoman is basically an opinionated workflow for creating beautiful, compelling web applications. And the idea is that you can kickstart new applications with minimal requirements for you to write your own boilerplate. And you can easily handle things like package management without having to do it in the very manual way that we do at the moment. So the way for you to handle package management right now is that you usually end up popping open your browser, going to say jQuery.com or Backbone.js, manually saving those assets locally, and then when someone tells you, maybe there's a new version, you have to go and repeat the exact same process yourself. And you've got to copy it back and forth between the applications that you use. Yeoman tries to make that a little bit more easy. So let's start off a new application with Yeoman. So we do this using Yeoman and init. And what init's going to do after it's done an update check is it's going to ask you a few questions about the type of application you're building. And by default, we give you the ability to use HTML5 boilerplate, jQuery, and Modernizer out of the box. We then ask you a few different questions. Do you want to use Require.js, the Bootstrap.js plugins? Do you want to support ECMAScript 6 modules? And then we go and scaffold out a very basic application for you. Now you'll also notice at the very bottom that this has scaffolded out some Mocha unit tests that you can use as well. We believe that unit testing is extremely important, so we want to reduce friction for people to be able to do things like that. Now, how do you normally handle things like getting your favorite jQuery plugins or getting whatever backbone extensions you want to use? Well, you normally do it inside a browser, but we think that we can do this a little bit more cleanly. So we've created a new Yeoman application, and let's say I want to find a new jQuery plugin. All I do is Yeoman search jQuery, and this is now going. This is using Bower under the sheets, but it's going and it's querying Bower, and it should, if the Wi-Fi is still up, hopefully return a bunch of jQuery plugins that are available here. Now all I need to do to use any of these plugins is do Yeoman install jQuery. Why not? Let's go for jQuery knob, whatever it is that does. What this has gone and done is it's going and it's fetching the latest version of jQuery knob. It's actually checking to make sure that jQuery is available locally in my application. If it isn't, it'll go and it'll fetch jQuery as well. So this actually has the ability to fetch an entire dependency chain for something that you're trying to do. Yeoman also has the ability to easily update dependencies. So if you update a dependency, it'll also update its dependency tree to make sure that you're always using the latest assets for your app. Another cool thing that we allow you to do is take care of your build process. So when you do Yeoman build on an application, not only will we go and use Grunt to concatenate and minify all of your files and optimize your project, but if you're using something like Require.js, we'll actually perform additional optimizations using RJS with that. We'll make sure that we generate you an application cache file and optimize all of your images and a bunch of other stuff. But one last thing that I'm going to talk about when it comes to Yeoman is our ability to avoid you having to write a lot of boilerplate for your apps. So you've seen me go and create an application that might be used for a very small single-page app. It doesn't actually seem to include any frameworks in it. We actually have really great support for scaffolding out things with frameworks. So if I go to Yeoman init help, what this will do is show me a list of all the generators or scaffolders that are available inside my application. Now, if you take a very quick look at this list, there's a bunch of them here. So we've got Angular, Backbone, Ember, and a number of others. Now, if I want to go and start a brand new Backbone application, let's just say, I can do Yeoman init Backbone, and that will go and it will scaffold me out a brand new Backbone application. It seems to have already noticed I'm in an existing app. So let's say back. So this will go and it will scaffold me out a completely brand new Backbone application using assets that are specific to Backbone. It'll also go and it'll create me my first set of application routes, views, templates, models, and collections. And if I go into any of these files, so if I go into the very last file that was created, so it's application collection, you'll actually see that this already has automatically namespaced my application using whatever name my directory had. And it's already hooked up the model to this, so I can go and start using this in whatever way that I want inside my app. Now, do I still have time? Okay. So apparently I don't have any time left, but I am going to ask people to check out one last thing before I go, and that's WebStorm. So WebStorm is this really cool new editor that allows you to basically live edit with Chrome in a way that you don't even need to be saving your files or anything. You can just be going and making changes directly inside your editor, and they'll be visible inside Chrome. So I've basically just taken an application that wasn't really working. There seems to still be some comments around here somewhere. But you can basically make changes inside your app and have those persist inside Chrome without having to save anything. And it also has great support for detecting what version of JavaScript you're currently using. So if it sees, for example, that I'm trying to use some ECMAScript 6 stuff, it'll actually say generators are not supported by the current version of JavaScript. So you can easily target versions for your application a little bit better than we can with things like Sublime. Please check out Yeoman 0.9.5 and learn to love your workflow and tools. Thank you.